Have you ever tried to fix a drafty window with one of those cans of expanding spray foam, and you just end up with this hardened, sticky mess that seems absolutely impossible to get rid of?
Oh, yeah. It is a classic DIY trap. You think it's going to be a quick fix.
Exactly. You press the nozzle, and it puffs up like some kind of science experiment gone wrong,
Right.
and then suddenly it's on your hands, it's on your window frame, it's somehow on the floor.
And it does not come off at all.
Right. Well, today we are saving you from a DIY disaster. Welcome
Yeah.
to the deep dive. We are looking at a really comprehensive professional guide today titled How to Remove Spray Foam Insulation Safely.
Yeah, and this source comes to us from Dumitru Nicolescu. He's the president of Green Attic Insulation up in Chicago.
Okay.
And he brings, over 25 years of construction experience to this guide. So we are getting a highly practical contractor level perspective on a problem that plagues, a massive number of homeowners and renovators.
Yeah, it's so common. So the mission for today's deep dive is to extract the ultimate tactical playbook for safely removing this stuff.
Mm-hmm.
We're talking about everything from dealing with a tiny accidental smear on a piece of baseboard trim all the way up to a full-scale, attic-wide removal operation.
Which is a whole different beast.
Oh, I bet. And the primary goal here is to figure out how to do it without completely destroying your house in the process.
Oh.
Okay, let's unpack this. Before we can even talk about the physical removal techniques, we have to understand the material itself. Like, why is this foam so notoriously unyielding once it leaves the can?
Well, it really comes down to understanding the timeline of its chemical state. Because there's a fundamental difference between fresh, uncured foam and fully cured foam.
Okay, so uncured meaning like right out of the can.
Exactly. When spray foam is fresh, like the exact moment it leaves the nozzle, it is an active chemical reaction. You have two separate compounds that are mixing and expanding right there in the air.
Right.
And if you catch the material in that highly reactive state, you have a very brief window where a solvent, like acetone, can actually interrupt the bonding process and dissolve the mess.
Okay, so it's similar to how you'd use like nail polish remover to break down wet polish before it sits on your nails.
Precisely the same mechanism, yeah. The solvent stops the polymers from linking together, but once that chemical reaction finishes and the foam fully hardens or cures, as they say, those polymers cross-link into a completely rigid matrix.
Oh, wow. So it just locks in.
It locks in permanently. And the guide points out a massive misconception here. People assume you can just go to the hardware store, buy a jug of some harsh industrial solvent, pour it on the hardened foam, and just watch it melt away.
Right, because that's what we do with paint or glue.
Exactly. But that chemical quick fix does not exist for spray foam. Once it cures, it becomes chemically inert.
Inert.
Meaning literally no common household chemical will reliably dissolve it.
Wait, I have to challenge that premise. In a world of incredibly advanced chemistry where we can engineer materials to withstand the vacuum of space, you're telling me there is absolutely no magic spray to dissolve window insulation. I just have to scrape it by hand.
What's fascinating here is the sheer irony of the material's design. The very properties that make spray foam an incredibly effective insulator are the exact properties that make it a total nightmare to reverse.
Oh, I see. Because you want it to be tough.
Exactly. The entire point of the product is its ability to rapidly expand, force its way into these microscopic crevices, and then harden permanently into a rigid, airtight, moisture-resistant seal.
Right, it's basically fossilized marshmallows fused to your house.
That is a great way to picture it. Its permanence is its core selling feature. Because the industry engineered it to resist breaking down over decades of extreme weather, you are forced to abandon chemistry. You have to rely entirely on mechanical force.
Wow.
You have to physically cut, scrape, or grind it away. There's no way around it.
So it's a permanent solution to what might just be a temporary draft?
Yeah.
You get this flawless seal, but heaven forbid you ever need to actually access the wall cavity underneath it later.
Yeah, you're locked out.
Now, you mentioned earlier that there are no common chemical solvents for fully cured foam, but the guide did flag one specific household oil that helps at the very end of the process, right?
Yes, there is one caveat there. If you have already used mechanical force to remove the bulk of the foam, right?
Okay.
And you are left with just a paper-thin smear, like a really thin residue on a surface, the guide notes that a small amount of mineral oil can actually help.
Mineral oil.
Yeah, but the mechanism here is critical to understand. The mineral oil does not dissolve the foam.
Okay, so what is it doing?
It acts as a penetrating lubricant. It works its way under the microscopic edges of that thin residue, breaking the surface tension so you can gently slide the foam off rather than aggressively scraping it and ruining the finish.
Got it. And the guide attached a massive warning to that tip, which I think we really need to highlight.
Mhm.
Mineral oil is not the same thing as mineral spirits.
Oh, huge difference.
Right, because mineral spirits are harsh, like paint-stripping solvents. But mineral oil is just the gentle stuff you rub into a wooden cutting board to keep it from drying out. I feel like mixing those up would be an absolute disaster on a finished indoor surface.
A very costly mistake, for sure. If you use mineral spirits, you'd end up stripping the varnish right off your hardwood floors or your expensive cabinets while just trying to lubricate a tiny piece of foam.
Yeah, that would be awful. So if you're standing in your living room, right, staring at a giant blob of hardened foam on your wall, and you know chemistry won't save you, how aggressive do you actually need to be with your physical tools?
Well, the required force and really the corresponding risk, they scale dramatically with the volume of the foam. The guide actually segments this into small, medium, and large jobs.
Okay, break that down for me.
So a small job would be that light overspray or a tiny patch from a DIY window seal like we talked about. The risk level here is low and it relies entirely on careful hand tools.
Like what?
Utility knives, hand scrapers, maybe a stiff brush, just simple handwork.
Okay, so moving past a simple smear. A medium job sounds like dealing with a thick buildup of cured foam covering a specific framing section.
Yeah, exactly. And that elevates the risk to medium. You still start with hand removal to take off the bulk, but you generally need to bring in light machine assistance.
Like power tools.
Yeah. An oscillating multi-tool becomes very useful here to just vibrate through the thicker sections. And that has to be paired with a vacuum to manage the debris.
Okay.
Then you have the large jobs.
Yeah.
This is widespread hardened foam covering entire roof decks or huge wall cavities.
That sounds intense.
It is. The risk level is classified as high. This requires staged mechanical removal, heavy-duty filtration, and just an extreme level of caution.
Let me pose a scenario based on that.
Mm.
Let's say I have a massive area of foam in an unfinished basement, right? And I own an oscillating multi-tool. My instinct is to just go full power. Like, I want to plunge the blade deep into the foam and shear it all off in one massive chunk to save time.
Sure, that's human nature.
Right. Why is the guide insisting on staged mechanical removal?
Because removing large patches of foam isn't demolition, it is an archaeological excavation.
Oh, I like that. Archaeology.
Yeah. You don't take a backhoe to a dinosaur fossil because you don't know where the dirt ends and the bone begins. With spray foam, you don't know where the insulation ends and your live electrical wires begin.
Wait, really? Just swallows everything?
Everything. The foam expands and swallows everything in its path. Plumbing pipes, delicate trim, structural framing, it all gets completely encased inside that hardened matrix.
That is terrifying.
It is. If you plunge a saw blade blindly into a giant blob, you run an incredibly high risk of slicing right through a live wire or a water line.
So you're flying completely blind. I mean, plunging a blade in is essentially playing Russian roulette with your home's infrastructure.
Exactly. And that blindness is severely compounded by the dust.
Dust.
Oh, yeah. When an oscillating tool vibrates through fully cured spray foam at, thousands of oscillations per minute, it doesn't slice it cleanly like a knife through butter.
Yeah.
It pulverizes the rigid foam matrix into a blinding amount of fine particulate dust.
Oh, so the air just fills with it.
The air completely fills with it. If you try to blast the foam off in one go, you won't even be able to see the wiring you were about to sever.
Wow.
That is the fundamental reason behind staged removal. You have to constantly stop the tool, grab the vacuum, clear the dust, inspect the newly exposed layer, and then proceed with another really shallow pass.
That sounds incredibly tedious. But, okay, if power tools blind us with dust and threaten to sever water lines, how on earth are we supposed to get this stuff off delicate surfaces without completely destroying them?
Well, the underlying material dictates your entire mechanical approach. You have to adapt the tool to the surface.
Okay, give me an example, like wood.
So wood might seem durable, right? But if you take a utility knife and dig aggressively under a blob of foam, those deep cuts will leave permanent gouges in the wood grain.
Ah, yeah, that makes sense.
So the guide insists on a shallow blade angle. You have to shave the foam down parallel to the surface. You're skimming it layer by layer rather than trying to pry it up from the root.
Okay, so shaving makes sense for a flat piece of wood. But what happens when this expanding chemical matrix forces its way into brick or masonry? Because brick is completely porous. You can't just shave that flush.
No, you can't. And masonry is arguably the most difficult surface to tackle for exactly that reason. The foam expands directly into those thousands of tiny pores and locks and like microscopic anchors.
Microscopic anchors, great.
Yeah, so if you take a metal scraper and just push it across the brick, you're acting like a lawnmower.
Okay.
You shear off the top layer of the foam, but you leave the pores completely clogged with the root of the material. Furthermore, aggressively prying with metal will inevitably chip the brick face or damage the mortar joints.
What do you even do then?
The strategy has to pivot completely. You don't start with a scraper, you start with a stiff bristle brush.
The brush.
Yeah, the goal is to mechanically agitate and fracture the material inside those microscopic pores first. You have to loosen the anchors before you ever attempt a controlled scraping pass.
Okay, I can see how that would work. But glass must be even more unforgiving. Say you got overspray on a window pane while trying to seal the frame.
Glass leaves zero margin for error. Any slip of a metal blade or a scraper creates a permanent, highly visible scratch right in the middle of your window.
Right. So you have to be super careful.
It requires the gentlest possible trimming to leave just the thinnest layer of residue. And once you are down to that microfilm of foam, you transition to the mineral oil technique we discussed earlier.
Oh, right, the penetrating lubricant.
Exactly. Using that to break the surface tension so you can slide the residue off without any abrasive scraping.
Okay, and I imagine painted or finished baseboards would be just as nerve-wracking.
Yeah.
The guide explicitly warns to always test any cleaning products or removal friction in a hidden spot first,
Always.
because you don't want to finally win the battle against the foam, only to realize you've completely stripped the finish off your expensive hardwood trim.
That is the worst case scenario.
Yeah, and this level of tedious, agonizing work naturally leads to a major question. I mean, do we really have to remove all of it? If there's an ugly, bulbous mass of foam sticking out of an unfinished wall cavity, can't we just chop the ugly parts off so it's flush and leave the rest buried in the wall?
Well, that is highly dependent on your end goal, which is why the guide defines 3 specific levels of intervention: trimming, partial removal, and full removal.
Okay.
What you just described is trimming. You are simply cutting the overexpanded foam back so it sits flush with the surrounding wall studs or framing.
And that's okay to do.
That is perfectly acceptable if the foam is healthy, doing its job, and simply needs visual cleanup so you can put drywall over it.
Good to know. So moving up a level,
Okay.
what dictates a partial removal?
Partial removal occurs when you need to clear a specific pathway without compromising the entire insulated wall.
Give me an example.
Imagine a plumber needs to repair one isolated pipe segment, but the entire wall cavity is filled with foam. You carefully excavate just that one channel to grant access. The primary challenge there is ensuring you don't accidentally shatter or disturb the adjacent foam blocks that you want to keep intact, because if you do, you ruin the home's thermal seal.
Right, which defeats the whole purpose of having it in the first place. Which brings us to full removal. Just tearing every last chunk out of the wall. When is that extreme level of intervention actually required?
Full removal becomes mandatory in a few specific, often structural scenarios. First, if the foam is actively blocking structural repairs, say a roof joist has rotted out, you cannot replace or sister that piece of wood if it is entombed in hardened polyurethane.
Yeah, you have to get it another way.
Right. Second, foam can obscure severe water damage.
So that's dangerous.
It is. Sometimes a roof leak will push water down behind the foam, trapping the moisture directly against the structural wood.
Oh, wow.
This creates an environment for accelerated rot that remains completely invisible from the inside of the house until the structural failure is, well, catastrophic.
Because the foam is covering it up.
Exactly. To locate the leak and assess the rotting wood, the entire foam barrier must be ripped out. And finally, full removal is heavily tied to the life cycle of the house itself, particularly regarding proper home inspections.
Right. And if we have to endure the dust, the risk to live wires, and the agonizing process of scrubbing brick pores just to achieve full removal, we really need to talk about the true cost. Like, when does a homeowner throw in the towel? Let's break down the realities of attempting this DIY versus calling a professional crew.
Yeah, the guide draws a very rigid boundary here. DIY removal is genuinely only viable for minor, localized cleanup in open, easily accessible areas.
So sealing a drafty door frame or fixing a small patch.
Exactly. The moment the foam becomes widespread or is buried deep in structural joints or is located anywhere near a home's utilities, electrical, plumbing, HVAC systems, a professional crew is absolutely required.
Because it transitions from a labor issue into a serious safety hazard. And actually, the guide highlighted some specific risks for older homes that elevate this far beyond just a standard renovation project.
Yes. Take the Chicago area, which Dumitru Nicolescu references extensively given his company's location. In older Chicagoland homes, taking an oscillating tool to foam near painted trim isn't just generating plastic dust.
Right.
It triggers the EPA's RRP rule, that's the Renovation, Repair, and Painting Program. Because of the era of those older homes, there is a very high probability of disturbing lead paint.
Wait, so I'm just trying to remove foam, and suddenly I'm dealing with lead paint.
Yes.
So the mechanical vibration of the tools pulverizing the foam is simultaneously aerosolizing lead paint into microscopic particles. You are pumping heavy metals into the air of your living space.
Exactly, the threat the EPA rule is designed to prevent. Safe mitigation requires specialized protocols. We are talking about professional crews suited up in Key 100 respirators, sealing off entire rooms to create negative air pressure zones, and utilizing industrial HEPA filtration systems to capture the aerosolized lead.
Yeah, you simply cannot execute that safely on a Saturday afternoon with a standard garage shop vac.
Not at all.
And bringing in crews with P100 respirators and negative air pressure zones obviously comes with a massive price tag. The cost comparison provided by Green Attic was a sobering reality check.
The baseline rates illustrate the disparity perfectly. To have a crew come in and remove standard old fiberglass bats from an attic, the industry average is roughly $1.40 per square foot.
Okay, pretty reasonable.
If you need blown-in cellulose insulation vacuumed out, you're looking at about $5.50 per square foot.
But when you look at the line item for spray foam removal, there is no standardized square footage rate listed. It's just blank.
Because establishing a flat rate is impossible. Spray foam removal is so intensely labor-dependent and so completely unpredictable in how deeply it has anchored into the home's specific framing that it requires a custom project-specific estimate every single time.
So you don't even know what it's going to cost until they look at it.
Exactly. You are no longer paying for standard insulation removal. You are basically financing surgical demolition by the hour. It almost universally costs significantly more to remove than any other insulation material on the market.
So you pay a premium to have it sprayed in for energy efficiency, and then you pay an exponential premium to have it meticulously carved out.
Right.
But, the financial twist in this guy that genuinely caught me off guard wasn't the hourly demolition cost, it was the impact on the real estate market.
Oh, yeah.
Like fixing your energy bill today with a heavy application of spray foam could actively sabotage your ability to sell your home tomorrow.
If we connect this to the bigger picture, the logic of the real estate market becomes very clear. Homeowners tend to view insulation purely as a utility, right?
Yeah, a barrier that traps heat and lowers the monthly gas bill.
Exactly. But a house is an interconnected system, and its structural integrity must be verifiable. When spray foam is applied heavily, particularly to the underside of a roof deck in an attic, it completely obscures the structural framing.
All right, it looks like a giant, rigid, puffy cloud has been sprayed over all the wood.
Yeah.
The rafters just disappear into the foam.
Now view that same attic through the eyes of a prospective home buyer, or a certified home inspector, or a mortgage lender. They shine a flashlight at that roof, and they cannot see the rafters.
Because of the cloud.
Right. They have zero visual confirmation of the structure's health. There could be massive systemic water intrusion, deep wood rot, or even active termite damage hiding beneath that impermeable, puffy cloud.
And they have no idea.
None. Because the foam acts as a visual blackout curtain, buyers, inspectors, and particularly risk-averse lenders will frequently demand the complete removal of the foam before they will sign off on the real estate transaction.
The bank will flat out refuse to fund the mortgage because the insulation is too aggressive. That is wild.
And the complications extend deep into local building codes as well. The guide points to the International Residential Code, specifically Section R316, and highlights the strict regulations in places like Chicago, which is classified as Climate Zone 5A.
Okay, let's break down why Climate Zone 5A matters here.
So in cold climates like Chicago, the winter air outside is freezing, but the air inside your house is warm and humid.
Right.
If a homeowner rips out spray foam to appease a bank and just leaves the bare roof deck exposed, that warm indoor air travels up, hits the freezing cold roof wood, and immediately creates condensation.
Oh, no. So it essentially rains inside your attic walls.
Exactly. That's why building codes demand the installation of vapor retarders. These are highly specific material shields designed to stop the home's internal moisture from reaching the cold wood and rotting the structure from the inside out once the foam is gone.
So you can't just tear the foam down. You have to engineer a completely new replacement moisture management system.
You do. Transparency of the home's structural health is just as valuable to the real estate market as a low energy bill is to the person living there.
This completely changes the entire perspective on home insulation. Let's briefly recap the tactical playbook we've extracted today. We started by understanding the unyielding chemistry of cured foam. We learned that the polymerization process creates a permanently inert matrix, meaning no magical chemical solvent will wash it away. The permanence is the product.
Which, of course, forces us into a mechanical battle. We learn that relying on physical force requires immense patience and an understanding of the surface. You cannot blast blindly with an oscillating tool without risking severing hidden wires or filling your lungs with dust. You have to adapt, using shallow shaving angles on wood and stiff brushes to excavate the pores of brick surfaces.
And finally, we uncovered the steep hidden costs. It's not just the expensive hourly labor of a professional crew setting up negative pressure zones to safely manage aerosolized lead paint. It is the complex real estate implications of obscuring your home's structural framing from inspectors and banks.
Every modification we make to a home has a life cycle. We have to plan for the eventual undoing of that modification, and spray foam is incredibly hostile to being undone.
So if you are standing in the hardware store this weekend, holding a seemingly innocent 12-ounce can of expanding spray foam to fix a drafty door, I guarantee you will treat it with profound respect. You now know exactly the kind of mechanical warfare, the dust, and the potential structural damage it takes to undo a careless 5-second mistake.
You'll definitely think twice about how much you really need to apply.
Without a doubt. But before we wrap up today's deep dive, I want to leave you with one final thought to chew on. While reading through Dumitru Nicolescu's guide, there was a brief, almost passing mention of persistent odor concerns as one of the legitimate reasons a homeowner might be forced to rip out all their spray foam insulation.
Oh yeah, that's a real issue.
Right. And it makes you wonder about the broader philosophy of modern home building. If the entire goal of modern insulation is to seal our homes up as tightly as a plastic bag to maximize energy efficiency and trap the conditioned air inside, at what point does trapping all that air actually compromise the very environment we live in?
That's a great question.
It's a delicate, unseen balance between saving money on your heating bill and the actual quality, flow, and safety of the air you breathe every single day. Something to think about the next time you find yourself trying to seal up every tiny, drafty crack in your house. Until next time, thanks for joining us on The Deep Dive.